Hi, I'm Chris, and today we're going to learn about the derivatives of an exponential function. The rule of thumb of deriving an exponential function is that it follows a formula as such where d over dx bracket of e to the power of u equals e to the power of u times d over dx bracket u. So u can be any equation that is to the power of e. So let us see this equation over here that we have, which is y equals e to the power of 2x. If we apply this formula over here, then dy over dx equals e to the power of 2x times d over dx, and differentiate what is in the power. So after differentiation of this, it will become 2. So we need to rewrite this, which will become 2 e to the power of 2x. Another equation that we have over here is y equals e to the power of 5x plus 2. By applying the same formula over here, dy dx will become, we rewrite whatever is in the original equation, then times d over dx of this power, which is 5x plus 2. So e to the power of 5x plus 2 times 5. Because the differential of 5x equals 5 and differential of 2 is nothing. So we are left with 5 over here. So we need to rewrite this, which becomes 5 e to the power of 5x plus 2. Now let's try another equation that's a bit more challenging. Here we have y equals to e to the power of 3x plus 5 squared. So by using the same formula, dy dx would equal, rewrite the equation, times the differential of whatever the power is, which is this whole thing here. So now we need to differentiate this part, which becomes 2 to the power of 3x plus 5. But don't forget, we also need to differentiate what is inside. So now we need to differentiate this part, which becomes 3, because the differential of 5 is nothing and 3x becomes 3. So we need to rewrite this whole thing. It becomes the final answer. Now let me introduce you to word problems that involves deriving exponentials. In this question, it says that a certain radioactive substance decays over time. The sample remaining after t years is given by this equation, where p is expressed as a percent. Question number A. Determine the rate of change of the equation. B. What is the rate of decay when 70% of the original sample has been decayed? Now jot this down and take note of this equation over here. You can pause the video and copy the question. So for number A, it says that determine the rate of change of the equation, which means that we need to derive this equation over here. So by using just now the rule of thumb, we could differentiate the equation like this. Your steps should look like this. When we rewrite this, your answer should be negative 2800 e to the power of negative 70. You can pause the video to copy the answer. So for the second part of the question, asks what is the rate of decay when 70% of the original sample has been decayed. We should use the original equation pt and sub in the 70%. And we know that 70% equals 70 over 100. We should sub this into over here, because p is expressed as a percentage. Now we need to move 400 to the other side. So your answer should be 7 over 4000. You can pause to copy the answer. Using the exponential rule, when moving e to the other side, it will become ln. So it should be ln 7 over 4000. And if we move negative 7 to the other side again, it should look like. So your answer should be t equals to 0.9069. Using this, we can find the rate of decay of the original sample. Feel free to pause the video to copy the answer. Using the answer we got just now, we can just sub it into t. So after subbing it into the equation, your answer should be negative 4.9t, which is the rate of decay. Again, feel free to pause the video and copy the answer. So now let me introduce you to the second word problem, which is a bit more challenging. The question says, the number of insects in a forest at a time t in months is presented as this equation, which is I of t equals 1000 bracket 30 plus e to the power of negative t over 10. A is what is the initial number of insects in the forest. B is determine the rate of change of insects over time at time t. C is how fast did the number of insects grow after 1 year. D is what was the highest amount of insects in the forest during the past 5 years. Feel free to pause and copy the questions. So for A, it asks what is an initial number of insects in the forest. We can use this equation over here, which is the original equation. Your equation should look like this. It is 0 because it's the starting point, so there's nothing, so it should be 0. After calculating, your answer should be 31,000. So for B, it says determine the rate of change of insects over time at time t. So just like the previous question, we need to derive the original equation to find the rate of change. So as usual, we need to derive it this way. So we know that we need to differentiate this part, since differentiating 30 equals nothing. And also don't forget to also differentiate the power, which would be negative 1 over 10. Your answer should already look like this. Now we need to rewrite it, which will become, so your answer should be negative 100 e to the power of negative t over 10. For the third question, which asks, how fast did the number of insects grow after 1 year? So, just now we calculated the derivative of the original equation. We should use this to determine how fast it grew within 1 year. So we know that 1 year equals 12 months. The reason we use months is because in the question it already stated that time t is in months. Using 12 months, which is the time, we can sub it into differential equation. By doing so, your equation should look like this, negative 12 over 10. So your answer should be negative 30.12, which is the rate of decay of the insects. So for the last question, it asks, what was the highest amount of insects in the forest during the past 5 years? So we know that 1 year equals 12 months, which means 5 years would equal to 60 months. Using the original equation, we would know the amount of insects that were living in those past 5 years. So your equation should look like this. 1000 bracket 30 plus e to the power of negative 60 over 10. So now we just need to calculate it. So your answer should be 30,003 insects. So comparing the two equations that we have over here, for the first question, it is noted that time is 0, which is the starting point, and it was 31,000. So comparing these two numbers here, so it means that the insects in the forest has decreased. So in conclusion, the largest amount of insects living in the forest was at the start of the first 5 years. Feel free to pause the video and copy the answer.